Hello, and welcome to our channel where we explore everything. This is the third video of the series, Create Your Own Automation App. Today we'll be discussing more detailed implementation aspects of our app, focusing on how we implement the core concept. Let's get started. Technically, the heart of our app is simply a loop. In this loop, we run each node one by one to the last connected node. In simpler terms, this can be likened to a program where the nodes represent lines of code, and the main function consists of a single loop that encompasses all the nodes. As mentioned in the previous video, we have two kinds of special nodes, triggers and start nodes. These nodes play a crucial role in initiating and controlling the flow of our automation app. The loop begins with the start node. The start node is crucial. It's the designated entry point for the entire process, and its primary function is to direct the execution to the subsequent node without performing any action itself. In other words, it simply points to the first node to be processed. The trigger nodes are equally vital. These special nodes define how the flow is initiated. For this experiment, we're creating two distinct types of triggers. Triggers based on scheduled times and triggers based on record operations like created, edited, or deleted. We'll discuss more into the specifics of each trigger type later in the series. Essentially, the triggers are the gateways that activate the automation. Without them, we'd need to manually initiate each flow every time. Now, let's move on to the nodes themselves. A node typically inherits from the base node class, which defines two core methods, process and getNextNodeInfo. These methods are the backbone of our automation app, enabling us to easily create complex workflows. The main loop of our application will repeatedly call the process method, passing it the result of the previous process as a parameter, allowing for data transformation and manipulation at each stage. To ensure simplicity and flexibility, we've established a convention that the output or parameter passed to the process method must be in dictionary format. This standardized approach simplifies integration and allows us to easily manage complex data structures within our automation app. Let's create a simple flow which displays a notification to ourselves, a practical example to illustrate the core concepts. To display a node, we need at least two nodes, the start node and the node responsible for generating the notification. We already have the start node in place, so now we need to craft the node that will actually display the notification. To create this node, we'll create a new class derived from the base node class and override the process method. Since our goal is to send a notification to ourselves, we first need to retrieve the user ID associated with our account, a critical consideration when designing flows intended for scheduled execution. When a flow runs on a scheduler, the environment is controlled by the Odoo bot. Consequently, the UID variable within the environment variables belongs to this bot. To avoid conflicts and ensure the process runs as we intended, our app introduces another UID variable within the context variable, specifically linking it to the user who created the flow. This allows us to send the notification message using the sendBus method of the corresponding user's channel. And that's it. The flow is complete. All we need to do now is to establish the necessary administration for the node, such as registering it within our system and defining their client-side components. Once these elements are in place, we can then use it in automation flows. For a more detailed explanation of node registration, please refer back to the previous video of the series. In the previous video, I demonstrated a simple node that utilizes AI to analyze data. Let's now examine the code behind this node. As you can see on your screen, we're leveraging AutoGen for this experiment. Upon initialization, we set up the assistant agent, preparing it for its role. When the node is executed, we pass both the system message and the prompt to the AI engine. To maximize reusability, we've implemented simple templating for the prompt, allowing us to dynamically inject values from other nodes into the AI's input. This demonstrates how we can easily integrate AI into our automation app. This is just one example of how we're pushing the boundaries of what's possible with automation. And that concludes our discussion for today. Thank you for watching. If you found this video helpful, please like and share it with others who might benefit from this tutorial. Don't forget to subscribe to my channel so you can stay up to date on all my experiments and tutorials.